Section 6.3, classifying statements. We're still in 6.3. We're going to talk about classifying statements right now, and then the next video will be on comparing statements. Let me say something in the beginning here. When you classify statements, you're only dealing with one compound proposition, okay? When you compare statements, you are dealing with more than one, and I'm going to give you examples where you're comparing just two, okay? But there's three designations you can use to classify one proposition: logically true or tautologous, logically false or self-contradictory, or contingent. Don't confuse those three terms with the four possible designations you can use when you're comparing statements. I'm just now talking about classifying a statement, and you only use the classifying designations for one proposition, compound proposition, not for comparing, okay? So when we talk about comparing, I'm going to give you four other designations, okay? So when you have one proposition, and I'll go ahead and circle that there, when you have one, you can classify it according to whether it's a type of proposition where its truth value is dependent on specific truth values. In a sense, the compound proposition's truth value is a function. We've already talked about that in section 6.2, but you can actually have some other propositions, which I'm just now going to introduce, where it doesn't matter what the truth value of the simple components are, it still doesn't affect the overall truth value of the compound proposition. And when that occurs, this is a proposition that the truth value is dependent on form alone and isn't a function of content. Content doesn't matter. And I will show you two examples. That would be logically true or tautologous, logically false or self-contradictory. These are kinds of propositions that it doesn't matter what the truth value of the simple components are, or content doesn't matter, because the way the skeleton is arranged, the form, that is what is determining the truth value of the overall proposition. Okay? So how do you do this? What you do is, when you're given a single compound proposition, go ahead and do a truth table for it. Then when the truth table is done, look under the main operator. Remember, that was the operator where, on the last video, I drew a big square around it, right? Big, long rectangle. And that looks pretty pathetic there, but you get the point. You look at there and you look for a certain pattern, and based on what you see when you inspect the final column under the main operator for that compound proposition, that's going to tell you which designation of the three to use. Okay? Logically true, logically false, or contingent. Okay? So why don't we just go and start doing some examples. Let's do an example of tautologous or logically true. Okay? We'll write this down here. Let's do black. Okay, let's say we have if G, then H. We have both if G, then H, then G. Then H. Okay? So the main operator here, this is a conditional. So the way, let me say that one more time in English. If G, then H, and G, then H. Okay? And let's make sure you understand the P's and the Q's. This is very important. The main operator is a horseshoe, right? So if P, then Q. Q and P can stand for anything. A simple component, a compound proposition. The Q, the H is the Q, a simple component. Whatever H stands for, hare, hares or rabbits, hares are fast runners. They could stand for that. The P is the antecedent. It's everything on to the left of the main operator horseshoe. The P happens to be a conjunction. Okay? It's everything in the bracket. All right. So let's go ahead and fill out a truth table for this. The number of lines is equal 2 to the n. I see two different alphabet letters, 2 to the 2. It's a 4-liner. divide that by 2, and that equals 2, which means you go to the very first distinct proposition, and you are going to switch to false after 2 lines. True, true, false, false. Okay, duplicate this. True, true, false, false, and then you divide that by 2, and that equals 1. This means the next distinct simple proposition, and it should be your last one if you're alternating every other line. True, false, true, false. Like I said, you could do this with your eyes closed, half asleep. This is very rote and robotic. Don't get intimidated about what I just did right here. Okay, we're good here. That's all done. This row's good. Now we've got some work to do here. This is a conditional. So true, true, conditional's true, true, false, conditional's false, false, true, conditional's true, false, false, conditional's true. So we're going to look at this one and this one to get the column under the main operator, at least inside the bracket, right? So for a conjunction, both have to be true. True, true, that is true. False, true, that's false. True, false, that's false. True, false, that's false. When you're comparing these 2 rows, right? There and there. Okay, now we've got this row and this row. And so we know what P is. P inside the bracket, this is the values. Now we're going to look at P and the Q. So P is true and Q is true. The horseshoe, you remember you're going to go to your definitional operator. You need to consult this now for the horseshoe and when we were working on what was in the bracket for the conjunction. And hopefully you're starting to get that memorized right now. Alright, we have false, false. That's true for a conditional. False, true. That's true. False, false. That's true. Okay, so under the main operator, they're all true, and so this is logically true or tautologous. Okay, now let's do another example here. Okay. All right, now I'm going to give you an example of logically false or self-contradictory. This means that it will be false under the main, all false under the main operator. Okay? So let's go and write that one out. We'll scoot this down a little bit. Okay. So here we have either G or H if and only if both not G and not H. Okay? So this is a 4-liner, right? How many lines is it? 4 lines, and this should, hopefully you're getting the hang of this, so we can speed this up a little bit here. So go to the first distinct proposition, true, true, switch after 2, false. Okay, duplicate that. True, true, false, false. Okay, the next one, true, false, true, false. Go over here, true, false, true, false. Okay, let's change colors here. Now we've got this all worked out. Thank you, statistician people. They've given us all possibilities here. Now let's do this one here. Okay, we have a disjunction. So you just need one true at least. Just one. If you see one true, it's true. Okay, here's the only one where there isn't one true. That would be false. Then we've got work to do here. Okay, this is a disjunction. Okay, we realize that the main operator inside the parentheses is a disjunction. But here, this one, I'm sorry, a conjunction. This is a conjunction. So we've got work here to do. If H is true, not H is false. If H is false, not H is true. If H is true, not H is false, true. So it's just the opposite. True, false becomes false, true. And then over here, you have false, false, true, true. So just paying attention to the blue, use these for the conjunction, okay? And this is false for a conjunction. You remember, you got to have both true for a conjunction to be true, and that's the only one there at the bottom. So we're going to look at this row here and this row, and let's do here, and we're going to decide what the final column is here. Now remember, you'll go to this again, and you're going to look under the biconditional definition of the operator, and a biconditional is true if P and Q are either both true, they're the same, or they're both false, right? Okay, so we look at here, we're going to look at that row and this row here, okay? So we have true, false, that's going to be false, right? True, false. True, false there is still false. They got to be the same to be true. True, false, that's false. False, true. So they're all different. They're all the opposite of each other. So they are all false, and that's why we would call this self contradictory, or self-contradictory, logically false. Okay. Okay, and let's go with one more example. The next one will be, let's go back up here, it's going to be contingent. Okay, and the contingent is under the main operator. The truth value, you're going to have at least one true and one false, and this means that this is a proposition that its overall truth value of the compound proposition is dependent, is a function, is determined by the simple components, and it's not dependent on form. So what you need for this kind is under the main operator, you want to see at least one true and one false. So let's see how this one pans out. Okay, so I mean, I already know how it's going to pan out, but okay, we'll come all the way down. Let's write this out. Okay, so we have if either A or not B, then B. If either A or not B, then B. Okay, number of lines, 2 to the n, it's 4 lines. Okay, you divide that by 2, equals 2, switch after every 2. So you guys know the drill here, hopefully. True, true. Oh my gosh, I am so bored because this is just so easy. Alright, you divide that by 2, and that equals 1. Now you switch to the next one, every other. True, false. True, false, true, false, true, false. Okay, now we got some work to do on this one. Now, just to make sure you guys understand, the B is the Q, and the P happens to be this disjunction, okay? Alright, so if B is true, not B is false, false, true. It's just the opposite, okay? False, true. Alright, and the B is taken care of. And what we want to do is finish this out. So what is the P? The P is a disjunction. So with a disjunction, we're going to use this column and this column. So true, false, there's at least one true. At least one true here. No, not even one true there. At least one there. Okay. So we're going to be working with that row and this one for the main operator underneath the horseshoe. Okay, so we're going to work here. True, true for the conditional is true. True, false for a conditional is false. See? True, false. We have one of each now. False, true is true, and true, false is false. So we have at least one true and at least one false. This is classified with the designation a contingent proposition. Okay, what we'll do in the next video clip is we'll talk about comparing propositions. That's when you have more than one. All we've done is classify one proposition, three possible designations. Logically true or tautologous, logically false or self-contradictory, or contingent.